Hey y'all, in this video we are going to go over the answers to the graphing motion practice worksheet. On the front side of this paper we're going to start with is has you construct a position time graph from each velocity time graph. So I've loaded in pictures of the answer key and we're just going to quickly talk through how to solve each of them. All right, so for number 1, you have a velocity graph that has a diagonal line that goes from 10 up to 20 seconds. So when you're finding to make a position graph, you need to find the area between the line and the x-axis. So when you do this, I've colored it in, and you don't get a perfect triangle or rectangle out of this. You get a combination. So I've color-coded those into the two shapes. So for the triangle, you'd have 1/2 times the height of the triangle. So it goes from 10 up to 20, so its height is 10. And it goes over from 0 to 4 seconds, so its time is 4. When you multiply that out, you're going to get 20 meters for your answer. And then for the rectangle part of it, its width is also 4. It goes over from 0 to 4, so you put in the 4 there. And then its height goes from 0 up to 10, so its height is also 10. You multiply those out, you get 40. When the shapes are stacked on top of each other like this, you are adding them together to get your total distance. So in this case, 20 plus 40 is going to give you 60. All right, then step 2 is to find whether it's constant velocity, speeding up, or slowing down. So in this case, you have a diagonal line on a velocity graph, so we know that means it's accelerating. And if your line is going away from x-axis, like this one is, that means you're speeding up because you started at a velocity of 10 or a speed of 10, and now you're going a speed of 20 when you're done. So that would mean you're speeding up. So we need to draw a curved line on our position graph that also represents speeding up. So we want it to get steeper at the end, which shows us speeding up. So we're going to draw our curve that looks like this with it getting steeper at the end. We want it to go for 4 seconds because we want the times to match. And then for where the curve's going to stop at, you're going to go up 60 meters. So we're going to always start at 0 for the first section of the graph and then go up or down by that much. So we went up 60, okay? All right, number 2, we now have 2 sections to our graph. We have a diagonal line that goes down to 0 and then one that goes underneath our x-axis. So now we have 2 sections. So you're not going to add these together like number 1 because they're separate. They're not stacked on top of each other. So for the green triangle here, it's 1/2 2 times 20 because it has a width of 2, a height of 20, and that equals 20 meters. And then for the red triangle, we have a width of 2 because it goes from 2 to 4 seconds, so it's 2 seconds long, and it goes down from 0 down to -10, so it's has a height of -10, and that's going to equal out to -10. And again, you don't add these together because they are not stacked on top of each other. So when you're drawing the position graph, you're going to go one after the next, all right? So we're going to start with the green. It goes for 2 seconds, so we're going to stop at 2. It goes up to 20, so we're going to start at 0 and go up to 20. Our diagonal line here is going towards 0. You were going a speed of 20. Now you're going a speed of 0 when you stop. So you're going to slow down. So we want a curve that gets flatter. Okay. For the second section of this, you're now going in the negative direction. So you're going to start here where you ended and go down by 10 because it equals -10. So if this were instead a positive 10, you would be going up. But since it's negative, we're going down. So we're going to go down -10. And then this diagonal line tells us we're speeding up because we're going away from 0. The fact that it's negative just means we're going backwards. But we're going at 0, and now we're going a speed of 10. Your car speedometer doesn't go negative if you're in reverse, all right? You put it in reverse, and that means you're going negative. So we are going down 10 and speeding up, so we have a curve like that, okay? All right. All right, for number 3, you now have 3 sections of the graph. We have every time your line changes direction, so we went from horizontal to diagonal, we want to split that up there. We want to split it every time it crosses the x-axis. All right, so for your areas, your green box is 4 times 4 is 16 meters. That one's an easy one. For your triangle, this one goes from 4 to 6 seconds, so its width is 2, and its height is 4, so that equals +4. And then the orange triangle has a width of 4 because it goes from 6 over to 10, so that's a width of 4, and its height here is -2. So that's going to equal -4 meters. For creating your position graph, for the first green box, it's a horizontal line, which means constant velocity. On a position graph, a diagonal line means constant velocity. So we're going to go up 0 up to 16. Then for the red triangle, we're going up another positive 4. So we're going to add 4 to our 16 because you went a constant velocity for 16. Now you went 4 more meters, but you're slowing down as you're doing that. So we're going to have that curve that gets flatter, and we're going to go up to 20. Then for the last section, we have now turned around and gone in the negative direction, but we're speeding up as we do it because we're going away from 0 on here, so we're speeding up as we go in the negative. So we're going to subtract 4 from 20, we're back to 16, and we're just having a curve that speeds up as we do that, okay? All right, last velocity graph. We have a 4-section graph now. We're getting more complex. So we have a triangle, box, and then 2 more triangles. So for the first one, your area is going to be 4, 1/2 times 2 times 4. The orange box is just 2 times 4. The red triangle is 1/2 for a height of 4 and a width of 4 equals 8. And then the yellow triangle is 1/2 times 2 times a height of -3, and that's going to equal -3. Remember, anything below your x-axis is going to be negative. Anything above it is going to be a positive area, like those 3. Okay, so then the hard part is making your position graph. So for the first one, your area was 4. You go up start from 0 and go up to positive 4. And then you want, this one was speeding up. You started at a speed of 0. You're now at a speed of 4. So you want a curve that shows you're speeding up. Then for that horizontal line, that means your constant velocity, all right? You're keeping that constant of 4. So you're going to have a diagonal line. Then for the red triangle, you are going from 4 down to 0. So that means you're slowing down, but you're still going positive. You're going up another 8. So we are all the way up to 12 now. We want to add on another 8. So 8 plus 12 is going to get us to 20. And we're going to slow down or get flatter as we get to that 20. Right? And then the last one, we are now negative. So we're going to start going back down on the graph, and we're going to go down by -3. So unfortunately, my y-axis scale prevents me from going, I'm a little bit above 16 here at 17. And I'm going to speed up as I get there because this diagonal line tells me I'm speeding up. I'm going from 0 down to -3. The negative just means the direction, all right? So you end up at 17 here, okay? All right, let's move on to acceleration graphs. I feel these are a lot easier to do because all you've got to do is find the slope and then put the line there. So for this first one, these are the same sets of graphs we just worked with. So for this first velocity graph, you go from 10 up to 20. So your rise here is 10. It goes from 0 over to 4 seconds. So your run is 4. Divide that out in your calculator and you get 2.5. So on your acceleration graph for the 4 seconds, you draw your horizontal line at 2.5. Okay. For number 2, you now have 2 different sections to find slope for. Anytime your line changes or crosses, not necessarily for acceleration, crosses the x-axis, but if it changes the slope, like you can clearly tell this does not maintain the same slope here. Okay. So the first section goes from 20 down to 0. So its rise is -20. And then its run goes from 0 to 2, so it's with this 2, or its run is 2, and that equals -10. And then the second section, you're going from 0 down to -10, so your rise is -10. And again, this run is also 2 seconds because it's going this time from 2 to 4. So that's 2 seconds wide. All right, so, or its run is 2 seconds rather. So that equals -5 when you work that out. So for your acceleration graph, you're going to plot the horizontal lines at those numbers. So the first 2 seconds, and time is not labeled here. This should be 2 seconds and 4 seconds. So you -10 and then -5. Okay, and then just put a little dashed line to connect the 2. All right, the third one, we now have 3 sections. Immediately, anytime you see a horizontal line on a velocity graph, you'll know the slope is 0. It's always 0, okay? Then for the next one, our rise goes from 4 down to 0, so it's -4, and it goes from 4 to 6 seconds, so that run is 2. When you divide that out, you get -2. For the next one, your rise goes from 0 down to -2, so that's a rise of -2, and it goes from 6 to 10 seconds, so that's a run of 4. Divide that out, and you get -0.5, all right? So then on your acceleration graph, you're going to put those horizontal lines at those numbers. So for the first 4 seconds, it's at 0. For the next, from 4 to 6 seconds, it's at -2. And then for the last 4 seconds, that's at -0.5, all right? And then again, just put the dashed lines to connect them. So you get this shape. All right, and the last one, you're again going to go find all of the slopes. So the first one slope is 2. The second one, it's a horizontal line, so you're smart, you automatically know it's a slope of 0. The next one, your rise goes from 4 down to 0, so it's -4. It goes from 4 to 8 seconds, so its run is 4. So that equals -1. And then the last one, its rise is -3 and its run is 2 because it goes from 8 to 10 seconds. When you divide that out, you get -1.5. So then for your acceleration graph, you plot those numbers. So the first one goes at 2, the second one goes at 0, and then the third one goes at -1 from 4 to 8, and then the last one goes at -1.5 for the last 2 seconds, okay? So that's all there is to acceleration graphs. Find the slope, plot the line, okay? They're really simple. Don't overthink it, okay? If you can find slope, you can make an acceleration graph from a velocity graph. But if you guys have any questions, just reach out to me and let me know. I'll be happy to answer them.